So this week's experiment was on nuclear bombs, just what makes them up, what they are exactly, and really how powerful they can be due to the chemistry inside of them. So obviously, we couldn't reproduce this experiment, but we kind of just took an inside look at what makes up these weapons of mass destruction. So there's two different types of nuclear bombs. There's the hydrogen bombs. These use thermonuclear fusion, where the energy from the initial detonation or fission fuses the hydrogen isotopes together. So its most effective element is lithium hydride. While it also uses a nuclear device with low power, this is the detonator. That triggers the thermonuclear fusion inside the bomb. This just facilitates the whole process. And honestly, there's really no limit to the power that these bombs can release, which honestly is pretty frightening. Even the video that was used as a source for this presentation, they said that it could hold up enough power to wipe out all life on Earth. So hopefully no one figures out how to do that, but that's how powerful these weapons can be. The other type is an atomic bomb. This is formed by a chain reaction of the fission of heavy nuclei. This is usually uranium-235, although there are other isotopes, 234 and 238. And this element should be at least 80% density in order to enrich this bomb further. This bomb can also be formed with plutonium, which is isotope 239, but this is artificially made. It's not naturally found in nature, and it can be created if something from the above element goes wrong. So for this bomb, a critical mass of the material is concentrated in one place, and you need about 4 to 5 critical masses in order for it to be a truly destructive weapon. So what happens is an explosive is on the outside of the bomb, and when that's detonated, the inside, which contains the uranium, expands, so it decreases the empty spaces inside and condenses the material, and this causes for a larger amount of uranium, allowing for greater destruction. So when reached, the nuclear decay reaction is formed, and this releases energy. So what makes up these bombs? These, like I said, these are weapons of mass destruction that use nuclear energy. They contain an atomic nuclei that is released during nuclear reactions or radioactive decay, similar to stars. So the basic components that are inside are the isotope of the element, like I said, normally uranium-235 or plutonium-239, and an explosive material that can be detonated from the outside. So the chemistry that's involved is typically a chain reaction. So as you can see in the graphic on the left, what happens is there's an initial detonation, and that's all that's really needed just to produce this fission reaction. And just one simple detonation of that initial element continues the chain down. So a neutron will pop off of that detonation, and that will continue the chain down. And when we study how powerful these bombs are, we use a TNT equivalent. So TNT is another form of explosive. So to measure it, we compare the amount of TNT that would be needed to produce this powerful explosion, and that is how we measure how powerful that bomb can be. So one other point that I just want to touch on real quick is the different types of radiation that these bombs can produce, because I think it's important to note, since it is a form of chemistry that really affects us. So there's 3 different types of radiation: alpha, beta, and gamma. Alpha, it can cause the least amount of harm to us. Basically, our clothes can protect our skin from it. It's not as penetrating as beta and gamma, and as you can see, even just paper can protect us from alpha. But the biggest point that we have to worry about for alpha is just our mucous membranes. So we can wear like masks and different things like that to protect us from it. Beta is a little bit more penetrating. We would need something like aluminum to protect us from it. It can cause a lot of damage just from a few meters or feet away from the radiation source, and it can cause things like radiation burns, cataracts, different things like that, which can be a little bit more damaging than alpha. Finally, the last type, gamma, it's the most penetrating, it's the most dangerous. Really the only thing that can protect us from it are thick sources of lead or concrete. And it can be really detrimental to our health. It can cause radiation sickness, cancer, and it can even cause gene mutations. What I really liked about this graphic that I found, it shows how penetrating it is. It shows the makeup of it. So alpha is made up of 2 protons and 2 neutrons. Beta is a high energy electron, and gamma is a high energy EM radiation. And it also shows the different uses that we have for these types of radiation in our day-to-day life, which I also found pretty interesting, considering it can be dangerous to us as well, you know. So yeah, that's about all I have to say about nuclear bombs. Although they have a fairly simple makeup, honestly, considering all it needs is an explosive material and then a specific isotope inside, they're very dangerous to us and the world around us. So I hope you learned something about nuclear bombs. Here are just some of the sources that I used, and thank you for listening.